Hello guys, so today we are going to see a new chapter in general physiology, and that is membrane potential. I am going to tell what is membrane potential, what is the resting membrane potential, what is equilibrium potential, and what is restless membrane potential, and finally the action potential. I am going to cover all this topic in this chapter. So in very simple way we are going to see what is membrane potential. Just say it's an animal cell, and the outermost covering of the animal cell we all know it's a cell membrane. So this is the outer side of the cell membrane, here is the inner side of the cell membrane. So if we'll take one voltmeter and one wire, if we will attach outer side to the cell membrane and the other end we will attach to the inner side, we are going to see that in the voltmeter we will see one reading or the deflection, and this is the potential difference which is generated either side of the cell membrane due to difference in the charges of the ions. So this is the membrane potential. So what is membrane potential? The difference in the potential which is created by the concentration, different concentration, which is created by the ions which is present either side of cellular membrane. So this is the membrane potential. Now we are going to see what is resting membrane potential. What is resting membrane potential? Just say that this is a cell membrane, this one is the inner part, inner side, and this is the outer side. So initially the more concentration of sodium ions are present inner side and less amount is outer side, less sodium ions. So what will happen, the efflux of sodium ions which is going to see outer side of the cell membrane and the influx of potassium ions guys, so we are going to see the resting membrane potential. So what is actually the resting membrane potential? As we all know that I have already told, this is the inner side, this is the outer side, here is the cell membrane. So in the inner side more sodium ions are present and outer side potassium ions there. We all know that the exchange of sodium ions and potassiums are always in the ratio of 3:2. So 3 sodium ion efflux outside of the cell and 2 potassium ion influx inside the cell, and the concentration of plus charge is more outside, at the negative charge is less inside. Sorry, the negative charge is more inside. So due to that, the inner side will be negative. So these cause the cell to be in the resting phase or non-excitable phase. So this is the resting membrane potential. The efflux of sodium ions outside will be more than influx of potassium ion. That will cause inside negative and cell will be in resting phase. So we are going to see the resting membrane potential of the nerve cell, which is minus 70 millivolt for the skeleton muscles, which is minus 90 millivolt. Cardiac muscles is also minus 90 millivolt. So this is all about the resting membrane potential. Next we are going to see restless membrane potential. What is a restless membrane potential? So it is nothing like if the potential of the membrane so if the potential of the membrane oscillate between minus 40 to minus 60 millivolt. So this is restless membrane potential basically seen in the pacemaker. So pacemaker where will be found? First, at very first we all know that in heart we will find the pacemaker, that is the SA node. Next, in gastrointestinal tract, that is the caudal cell. There also the pacemaker is there. And third, Bötzinger complex. Where will find this Bötzinger complex? This is basically related with the breathing. This is found in the medulla region of hindbrain. Now we are going to see hypo and hyperkalemia. So what is hypo and hyperkalemia? It is all about potassium ions. And so always remember, whenever we are going to study the membrane potential, always remember, most of the time we are going to say, or we are going to study with the respect of the inner side of the cell membrane. So in the case of hypo, as we all know, the word hypo represents less. So less potassium ions inside the cell membrane or inside the cell. Hyper means more potassium ions inside the cell. So just say it's a cell membrane here. This is the outside, here is inside. So what happened in the case of hypokalemia? The most of the ions, potassium ions present inside the cell will diffuse out. The diffusion of potassium ions occur, and finally inside the cell very less potassium ions left. Most of the potassium will be outside. This cause hyperpolarization. So always remember, this hyperkalemia always do the hyperpolarization. It is responsible for the hyperpolarization. Now we will see the hyperkalemia. In the case of hyperkalemia, more and more potassium ions will be attracted inside the cell, which is responsible for depolarization. Okay, so this is all about hypo and hyperkalemia. In the hypokalemia, there is a less number of potassium ions left inside the cell, which cause the hyperpolarization. In the next way, we will see the hyperkalemia. In the hyperkalemia, lots of potassium ions will be left and can't effuses out of the cell, and it is responsible for depolarization. Now we will see equilibrium potential. What is equilibrium potential? What is the meaning of equilibrium? Equilibrium means balanced, both sides, inner side and outer side. So what will happen if the concentration gradients, means ions, if the concentration gradients is same as electrical potential, the net flow of ions will be 0. So this is the equilibrium potential. So now we have some formula. From that we can now we have some formulas. From that we can derive the equilibrium potential of the cell. We will see here the equilibrium potential of some of the ions like sodium, potassium, chloride. For the sodium it is plus 60 millivolt, for potassium minus 90 millivolt, for chloride minus 70 millivolt. So please do remember the equilibrium potential of chloride ions is same as the resting membrane potential of nerve cell. Now we are going to see how to find the equilibrium potential. So to find the equilibrium potential, basically we have two formulas, or we have two equations. So we will see one by one both. First is Nernst equation. Second is Goldman equation. So Nernst equation we can find the equilibrium potential of only one or single ions, either potassium, calcium, sodium or chloride ions. If the number of ions will be more than one, so we are going to see the Goldman. So for find Goldman equilibrium, we need two parameters. First is concentration, second is the permeability. First we will see the Nernst equation. So we have two formulas to find the equilibrium potential One is a Nernst equation and the second was the Goldman equation. For the Nernst equation, we can find the equilibrium potential for a single ions. If there is only one ions, then only we can find or we can use the Nernst equation. But if there will be multiple ions, in that case we can use the Goldman equation. So let's see. It can be found in two ways. First is using the Nernst equation. Second is Goldman equation. Nernst equation can be used for a single ions. Either it can be sodium, potassium, calcium or chloride ions. But if more than one ions will be there, in that case we are going to use, just say if sodium, potassium, calcium, all three are together, in that case we will use Goldman equations for multiple ions. Okay, so let's see Nernst equation. The Nernst equation, that is equals to equilibrium potential plus minus 61 log concentration outside by the concentration inside of an ions. So this is a formula. Let's see how we can derive this formula. As we all know that from the Gibbs free energy, delta Z equals to G standard plus RT log K. K is the concentration, and from the electrochemistry we know that del G is equals to minus NFE. So if we'll put in the case of delta Z, so it will be minus NFE, and if we'll put by replacing the G naught, means a standard Gibbs free energy, then we need to put a standard potential, that is E naught plus RT log K. By dividing both sides with minus NF, then we will get E is equals to E naught minus 0.059 by N log K, and K is the concentration inside by concentration outside of the ions. So after solving this, the standard potential is equals to 0. So after solving this, we will get this equation: plus minus 61 log concentration of an ions outside of the cell by the concentration of the ions inside of the cell. Now we will do one question. A muscle cell having a chloride ions have a chloride ion with concentration (11 millimolarity) inside and 110 millimolar outside of the cell. Find the equilibrium potential of the muscle fiber or cell. So how we are going to approach this? After seeing the question, very first we need to see the data. The data has been given. The concentration outside is 110 millimolar and the inside is 11 millimolar. So we remember the formula. Here a single ion is there, so we are going to see with the Nernst equation. So equilibrium potential is equals to plus minus 61 log concentration inside concentration outside by concentration inside. One more thing I forgot to tell you. If you will write the concentration outside, concentration inside up and concentration outside down, it doesn't matter, because here the sign will be, I will tell you what will be sign. Either it could be plus or minus, but for the plus or minus, how we have to know? I'm going to tell you. Wait. Plus minus 61 log 110 by 11, which is plus and minus 61 millivolt. Okay, so this is the answer? No, this is not the answer. If we'll get this type of question, we have to write the sign also, because in the 4 or 5 option there will be plus 61 millivolt. So what will be the charge? Tell. See here. This is a cell. outside concentration is 110, inside is 11. So to be equilibrium, what will be the direction of the charge flow? So direction will be outside to inside. So this is potassium ions, chloride ions. Okay, so we will see that the charge moving inside will be negative, more negative. So the charges will be minus 60 millivolt. If this will be opposite, if 110 will be inside, just say if 110 will be inside concentration and outside will be 11, then the net movement will be outside, so inside will be positive. So negative charge moving outside, so it will be positive. I told you before only, all this membrane potential chapter we have to see everything with respect to the membrane. Okay, inside the membrane, inside the cell, we have to see inside the cell all the charges, everything, positive, negative. Why we have to see inside the cell? Okay, a cell is there, let's say it's one cell is there and it is covered with the membrane. Outside will be the interstitial region. So how we can we can't define with outside until unless we will see from inside. So inside we have to focus more in this chapter. Okay, how I told in hypokalemia and hyperkalemia, like the charges of the concentration of the potassium in the case of hypokalemia will be less inside. Okay, and in the case of hyperkalemia, the concentration of potassium will be more inside. So all the time we have to see the inner cell concentration. Like that, in the question given 11 millimolar concentration is inside. So to be in equilibrium, so it has to move inside from outside concentration more. So that's why the chloride ion is there, so negative concentration increases inside, that's why it is negative. Okay.